Okay, so any questions on this one? We like this? Okay, so what was the next one you did? 49, I think? I'm not going to do all of 49, but we'll start it off. That's fine.
49.
49, thank you.
Yep.
We'll start it off. The closest distance, so it would have to be the distance of the perpendicular line. Exactly. So you're looking at dropping a perpendicular like this, right? So you're trying to find the distance. Let's label that, I don't know, A. You're trying to find P1 to A. Are we okay with that?
X, Y.
You're saying B is X, Y? Okay, that's fine.
The equation is AX plus BY plus C equals 0. So it is
X, Y. Okay, sure. Okay, sure.
And so I found the vector.
You agree with that? The slope of this line right here is negative A over B. We're okay with that?
Yeah.
The slope of a perpendicular line, two lines are perpendicular in two space if the product is negative 1, right? So therefore what's the slope of P1 to A? B over A, exactly. B over A. Awesome, awesome. Okay, so what'd you do next? So yeah, now is it just a matter of doing the math out? Yeah, now it's a matter of doing the math because you know P1A is going to be AB. And what's P1B?
It's X minus X1.
Yep. Comma.
Minus
Y1. Exactly. This is being recorded. Over what?
over square root of.
Well, it's this, right? Like that? Now, I'm not going to do it all out, but if you do it all out, do you end up with the right thing? What do you end up with?
I end up with.
They actually give you the endpoint, right?
Yes, but you have to transform one thing.
Okay. The key to it all is this realization right here. Until you write that, you don't have traction to move forward. It's very hard to go anywhere. Eh? Cool? Okay. 50 degrees west. So what does that mean, just in plain English? What does north 50 degrees west mean?
40 degrees above west.
Or, what's another way to say it?
50 degrees. Yes.
Exactly, yeah. So you can either say it's going to be so you go north, and then what do you then you turn 50 degrees towards the west. Exactly. So you have 20 pounds acting that way. And how far? It has to go 4 pounds this way. Sorry, 4 pounds. 4 feet. So force is, so what is this? Work is equal to what?
F cosine.
Well, F dot D, right? Which is going to be the same as what?
Magnitude F, magnitude D.
Yep, thank you. I just want you to write this out a couple times before it starts to get, times what?
Cosine theta.
Cosine theta, right? So in this case, the magnitude of the force is 20 cosine of,
40.
yes, exactly. So it's just going to be 80 cosine 40 degrees. Absolutely.
Decimal.
Nah, it's okay. That's okay.
Now, what is a foot pound? I know it's.
Yeah, okay. So here's the fun thing about a cross product. Here is the manipulation. A cross product is strictly defined only done between two vectors in 3 space. Only done with 2 vectors in 3 space. That's V sub 3. I'm notarizing that right here, V sub 3. If A is that vector and B is that vector, then the cross product of A and B is that vector right there. A cross B is A2B3 minus A3B2, comma, A3B1 minus A1B3, comma, A1B2 minus A2B1. Do I have you memorize that right there?
No. Yeah.
You could if you really want to. Is there a better way?
Probably.
You'd hope so. Anytime you see something that ugly, you hope there's a shortcut, and there generally is. Square matrix. The determinant of a 2 by 2 matrix is pretty easy. If it's A, B, C, D, it's A times D minus C times B. Those are the diagonals of that square. When you're doing a 3 by 3 determinant, here's the classic way of writing it. It's A1. So look at A1 here. This is important that you see this. A1 is in the upper left. What row is that in? What column? So we're going to eliminate those two. Which matrix are you left with? B2, B3, C2, C3. Okay? If you eliminate, what about A2? What row is that in? First row,
First row and second column.
second column. It's eliminated. What are you left with? B1, B3, C1, C3, okay? And for A3, it's the same thing. You're left with B1, B2, C1, C2, right? The most common thing people miss. Can someone tell me what one symbol up there that people miss the most often? The minus. The minus, the minus. Or the plus, depending on how you're looking at it. It always goes plus, minus, plus.
Minus, plus,
If there's a 4x4. If it keeps on going, it's going to keep on alternating. Absolutely right. But in this case, it goes plus, minus, plus. So each of these, what is that right there? What's this right here? What's that right there? Those are all 2x2 determinants. So you can take a 3x3 and break it down into 3 2x2s. We're not going to go any further than this, but if you have a 4x4 determinant, you can break a 4x4 determinant into 4 3x3s. Each of those 3x3s is 3 2x2s. So it's actually 12 2x2 determinants, right? Does this get really big if you have high, huge, large square matrices? Sure. Yeah. Would you? That's exactly. That's why you do it on your computer. Absolutely. 3x3s, on the other hand, pretty simple. There's a shortcut for 3x3s, which only works for 3x3s, which is useful because you sometimes have to do 3x3s by hand. That's the limit of what I will force you to do by hand if I'm in a good mood. Okay. The only thing you need to remember for the shortcut is this. That's not some Street Fighter move, but it's down, 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 up, 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 okay? Yeah. Down, right, left, right, A, B, start. Yes, I got it. I know. Okay. Copy the first two columns over again. So we have A1, B1, C1, A2. Congratulations. Keep it to yourself. Down, 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 up, up, up. You go down, down. I just did my diagonal. It was very bad there. Down, down, down. And then what do you do? Exactly. Then you go up, up, up. Each of those right there is multiplication. So what I mean by they are in different directions, but be more specific. They're going exactly opposite directions. Ah, okay. This is important, everybody. This is very, very important. So does the order matter when you do the cross product?
Yes.
Yes, it does. Both vectors are perpendicular to A and B. Do you agree? So if you have two vectors floating out in space, you have A floating out in space and B floating out in space. C can either go straight up, it's perpendicular to both of them, or it could go straight down. How do you figure out which direction it's going to go in before you actually make the computation? Well, there's something called the right-hand rule. Some of you asked about that before, right? We want to show that the vector A is orthogonal to what vector?
A cross B.
A cross B. Well, let's not just do it. Well, we know what A cross B is, right? What is A cross B? It's right up here. We figured out there's A cross B, right? Well, we hope it's 0, right? We really hope it's 0. Are you okay? So we make that substitution, and what do we do? So you do A dot, and what is A in this case? Sorry. A1, comma, A2, comma, A3, and we're dotting it by A2, B3 minus A3, B2, comma, A3, B1 minus A1, B3, comma, A1. Please make sure I don't make a copy error. It's so sad when I make a copy error. So if you do these out, when I actually dot these out, what should happen to the 6 terms?
All cancel out.
They should all cancel. They will. I will tell you that they will cancel. Is that okay? Are you okay with taking that on faith?
Yes.
You're just like, thank you. Thank you so much. Geometric equivalent for this, which is kind of neat. If you have a vector A,
2 space or 3 space?
let's go for 2 space right now. It doesn't really matter, actually. We're in 3 space, but we're going to operate on a plane for this. We're going to operate on the plane that these 2 vectors make. Okay, so both. Okay, if I drop, and I'll change colors here. If I drop this right here, and we'll call this theta. Do we know how to find the angle between 2 vectors if they're in 3 space? We learned how to do that last week, right? So could we, if I gave you A and gave you B, could you find theta? Absolutely. Okay, so if I continued to draw this And that's supposed to be parallel, but it's not. Let's put B. That's B, also B. And this is also A. What kind of shape is that, or what is that supposed to be?
Parallelogram.
It's supposed to be a parallelogram. It's a really poorly drawn parallelogram. Exactly, right. Okay. So, can someone tell me what the height of this parallelogram is?
H.
Yes, congratulations. It is H. Good answer! What is it?
A times sine theta.
Okay, you want to use sine? Okay. So we know that, I'll write it this way. Sine of theta is equal to what? H over A. Is that okay? I always have to do that in my head to keep it simple. I tend to reverse them. I don't like doing that. So, therefore, what does H equal?
A sine theta.
Well, in this case, it's the magnitude of A. We have to be really careful, right? H is equal to the magnitude of A times what? Sine theta, okay? What's the area of this parallelogram? The magnitude of B times H, right? But that's the magnitude of B times what?
Oh.
Magnitude of A
Sine theta.
sine theta. This is pretty cool. So did we actually just write the same thing? We kind of did. This right here is the same thing as that right there. So we also now know that the magnitude of the cross product of two vectors is equal to the area of what? Yes. Cool, huh?
What is the direction?
What?
Well, it's an area, so
A cross B is a vector. It's a vector. It's a vector. It's perpendicular to both A and B. The orientation is defined by the right-hand rule. So if you put your right hand up and sweep it out, your thumb is pointing in the direction of the vector. And the length of that vector is the magnitude of A times the magnitude of B times sine of the angle that they make. Ready for